Hey everybody, let's look at one more lesson on inverse trig functions today. This time we'll investigate cosecant and secant and cotangent. Inverse trig functions can be expressed in arc form or in exponent form. And here's what I mean by that. Let's take a look at exponent notation. Verbally, when I see secant inverse of 2, that means we're looking for an angle whose secant is 2. Also, it can be thought about as an angle where the cosine is 1/2 because secant's reciprocal is cosine. In arc notation, we can also write using cosecant inverse of 1 means that the radian measure of the arc on the circle that corresponds to the value where the cosecant is 1. So arc cosecant is the same thing as arc sine of the reciprocal, or cosecant inverse is the same thing as sine inverse of 1 over x because they're reciprocals of each other. So whether you use the exponent form cosecant inverse or the arc notation, arc cosecant, they mean the same thing. Here's the exponent notation for cotangent inverse, and you can write tangent inverse of 1 over x if you have positive x values, or you can add pi to that if you have negative x values, and if x is 0, it would be pi over 2. You can also write that as pi over 2 minus tan inverse of x and take care of that. So the arc notation doesn't take into consideration the angles where cotangent is 0. So the previous formula is preferred, these over here. So let's look at some of those properties. Recall from our earlier studies that we already restricted the domains for secant, cosecant, and cotangent in order to make those one-to-one relationships. So here they are again, just for refreshing your memory. We want to look at the graphs, and this time we're going to sketch the inverse trig for the other unknown cosecant, secant, and cotangent. So here's my graph of the cosecant function. That's my parent function, and I want you to pay attention to this region in here because this was part of our domain restriction. We looked between negative pi over 2 and 0, and then we want to look from 0 over to pi over 2 for the other piece of that restriction. And in that way, between this half and this half, we've taken on every value of the cosecant curve. So what we want to do is to graph those values. So at negative half a pi, we have negative 1. That means we can come over here to our graph for the inverse. This is the cosecant inverse, or arc cosecant, whichever method you prefer. And instead of having negative pi over 2, negative 1, we'll have negative 1, negative pi over 2. And then notice as we get closer to 0 that our values go down. So as we get larger values this way, our values are going to get closer to 0 if you follow that type of logic. So it's going to behave that way. So we flipped the x's and the y's in our inverse function. And likewise on this other piece, we have pi over 2 is 1. So over here we'll have at 1, we have a positive pi over 2, since we interchange the x's and the y's. And at a half, I'm a little bit bigger than 1. So at a little bit bigger than 1, we're at a half. And at a quarter, we're at 2. So at 2, we're at a quarter. You see how that behavior goes? So we're going to be asymptotic like that. Now, depending on which calculator, if you want to check this with your calculator, if you have the TI-84, you're looking for sine inverse 1 over x. But if you have the TI-Inspire, you can actually plug in cosecant inverse on that tab key. I'll show you with my example here. See the Trig key? If we press Trig key, there's cosecant inverse. And you can substitute that in and graph that using that Trig button and coming over to the inverse cosecant of x, and it'll graph that we have here on our screen. So 1 pi over 2 and -1 negative pi over 2, and we have those graphs. Okay, so cosecant, we restricted the domain to cover all the values, and that way we could graph the cosecant inverse. So our next example, the same thing. Again, if you're using your calculator on the TI-84, you're going to want to put in the reciprocal. So cosine inverse of 1 over x will give us the secant. And on the Inspire, we can just ask for the secant inverse function. And just like we did before, we want to consider those restrictions between 0 and pi over 2. So we're going to look at this piece of the domain, and then we're going to look at pi over 2 all the way to pi, so this piece of the domain. And from these two branches, we're flipping the x's and the y's, interchanging them, so that the y is the x and the x is the y. So like in this example, we have 0, 1. So over here, we're going to have 1, 0. And if we move over at a half, we're a little bit bigger than 1. So at a little bit bigger than 1, we're at a half. And that branch would go off that way. And then on this piece over here, if we have at pi, we have -1. So on this inverse function at -1, we have a point at pi. And same way, if I come over here, I'm getting closer and closer to half of a pi as we move to half a pi here. So that piece is going to go that way. And then we can verify that with our calculator, that our secant inverse function behaves like this, using that feature on the calculator, secant inverse. And again, I'm using my Inspire. So that function does look like our graph right here. We have an asymptote at pi over 2 because it's an asymptote on the original function as well. Okay. And then our last one is going to be tangent. So the tangent curve in this one is relatively simple because we're just going to look at the basic parent function between, I said tangent, didn't I? I meant cotangent. We're just going to look at this one, the parent function between 0 and pi, and interchange the x's and the y's so that we have pi over 2, 0, and on our inverse we have 0 pi over 2. Here we have pi over 4 and 1, so at 1 we have pi over 4. And here at 3 pi over 4 we have -1. So on our inverse we have -1, 3 pi over 4. We're going to have an asymptotic behavior at pi and an asymptotic behavior at 0. And that graph would have an infinite domain, but a limited range. Okay, so those are how the cotangent, secant, and cosecant inverses look. And here's some that we can practice with the thinking. So when you see the mark arc cosecant of 2, you can think to yourself about the unit circle. You're thinking, where is the angle for sine 1/2? Because the reciprocal of 1/2 is the cosecant, and the cosecant would be 2. So arc cosecant is 2, where sine is 1/2. That means the cosecant inverse, which is the same as arc cosecant, that means that is going to happen at pi over 6, because the sine at pi over 6 is 1/2, and the cosecant at pi over 6 is 2. So our cosecant inverse of 2 would happen at pi over 6. You follow that logic? So we can think to ourselves here, this is secant inverse. We're looking for negative square root of 2. So where would the cosine of our angle be 1 over square root of 2, negative, which is also negative square root of 2 over 2 when we rationalize. And that happens at a 45-degree angle, but where cosine is negative on a restricted domain would be between 0 and pi. So our secant inverse of negative square root of 2 would happen at 3 pi over 4. That's in the second quadrant, and that's on our specified domain for the inverse. On letter C, we're looking for cotangent inverse of radical 3. So we're asking ourselves, what angle is the tangent square root of 3 over 3? Oh, it's negative on my notes. It's not negative on this slide. And that has to be in the domain for cotangent. And the cotangent inverse is going to be negative radical 3 at 5 pi over 6. And then this last one, the arc cotangent of 1, is asking us where is the tangent equal to 1. So we can answer that question, where is tangent equal to 1? And that happens at pi over 4. So the arc cotangent of negative 1 is pi over 4. Oh, wait a minute. This is where my negatives got off. I have 2 mistakes on this slide. This is supposed to be positive 1, and this one is supposed to be negative radical 3. So I'll be sure to change that so your teacher has the right one. In this example, we want to do similar to our last lesson where we actually found a triangle that met these conditions. So when we're looking at this, the first thing I see is that we have a secant angle that has the ratio of negative 3 over 2. So let's think about that. The secant is the reciprocal of cosine. Cosine is adjacent to hypotenuse. So secant will be hypotenuse divided by adjacent. Now we can't have a negative for the hypotenuse, so that forces our negative to be on the adjacent or on the x-axis. Okay, so we can set that up that way. The second thing you want to do is find that missing leg. So a squared plus b squared, which is our y value, is going to have to equal c squared, which is 9. So y is going to be the square root of 9 minus 4, which puts this leg as the square root of 5. So on this graph, we move negative on x and positive on y to get that hypotenuse of 3. So the third thing we want to do is actually use the calculator and ask ourselves, using the calculator, what's the secant inverse of negative 1½ That's going to tell us our angle measurement. So we need the calculator, and secant inverse. Now again, if you're using the TI-84, you're going to have to use cosine of 1 over negative 1½. But on the Inspire, I can just ask secant inverse of negative 1.5, and that looks like 2.301. So the angle in radians is about 2.301 radians. And then if I want to convert that to a decimal degree, we can multiply that by 180 and divide by pi and get a decimal approximation of about 131 degrees. Or we can say it's about 131.81 degrees. So either one of these, depending on what your teacher prefers. Radian or degree measure. And here's one for you to try. If you want to turn off the video, you can try this on your own and then come back to follow my work. So I'm asking myself where the cotangent of an angle has the ratio of 1/2, and tangent is opposite to adjacent, so cotangent would be adjacent over opposite. And if this is my angle of interest, adjacent is 1 and opposite is 2, and this looks like a squared plus b squared is c squared, so our c is going to be the square root of 5, since a squared plus b squared equals the hypotenuse squared. So 4 plus 1 is 5, and the square root of 5 is our c. Then jumping over to the calculator, cotangent inverse of 1/2 is the angle that we're interested in. What's the measure of this angle? So cotangent inverse, or arc cotangent of 1/2 is 1.107 radian. And if I want the degree measure, 180 divided by pi, about 63.43 degrees. So the angle that we're interested in is about 1.107 radian, or 63.43 degrees, depending on which is the preferred answer. And then example 5, we want this is a composite function now. So not only do I have to draw the triangle, I also have to find the cosecant of that angle of interest. So first of all, we want the cotangent of our angle to be 1/2, and we said earlier that would be adjacent divided by opposite. So this is just the same triangle. If this is our angle of interest, and adjacent divided by opposite puts the square root of 5 as the hypotenuse. So our C value is radical 5. And then I can answer the question. So now I have my picture of my right triangle whose ratio for cotangent is 1:2. And the question's asking us what's the cosecant of that angle. So that's what we're interested in. And the cosecant is the ratio of the hypotenuse to the opposite. So to answer the question, the cosecant for the cotangent inverse of 1/2 is hypotenuse divided by opposite, or square root of 5 divided by 2 in this case. So we first had to resolve the triangle to get the angle of interest, and then we could take that triangle and get the relationship for the cosecant of this angle. This is an angle here. Example 6 is one for you to try if you would like, and then come back to check your work. So we're setting up the cosecant of our angle, and we need the ratio of -2, and it's got to be a fraction whoop, something's going on there. Let's get rid of all of that. Okay, so it's got to be a fraction, -2, so we'll use 1 for our denominator. And cosecant's ratio is hypotenuse divided by opposite. So we've got hypotenuse is -2, that won't go, and opposite. But we could make hypotenuse +2, and opposite could be -1, which makes sense in this fourth quadrant. And then we want to find the missing leg, so we are looking for x this time. X squared plus -1 squared is going to give us the hypotenuse squared. So x squared is going to be 4 minus 1, and take the square root of both sides. That puts the x-axis 3 under the radical. So radical 3 to the right, and 1 down, and 2 for the hypotenuse. Now we can answer the question. What's the secant of the angle of interest that we just drew, which is hypotenuse? Secant is hypotenuse divided by adjacent. So the composition, the secant of the cosecant inverse, that's -2, is going to be 2 divided by radical 3. But when you rationalize this, we would end up with 2 radical 3 over 3 after it's rationalized. So that's pretty straightforward. And then finally, this is all about using the calculator. And again, we're going to convert from radian measure in 3 decimals, and we're going to also write degree measure to the nearest hundredth in 2 decimals. So let's give that a go. So secant inverse of 4, secant inverse of 4 is 1.318, and then we're converting that to a degree measure for 75.52 degrees. So we either have radian measure as 1.318 or degree measure as 75.52 degrees. The next one, cotangent inverse, -1, or cotangent inverse 3/4, I'm sorry, 3/4, we're going to just put that as 0.75. So we got 0.927, and then converting that to a degree, multiply by 180 and divide by pi for our multiplier, and we have about 53 degrees. So in this case, the radian is about 927 behind the decimal, and 53 13/100 degrees. And then our last one, the arc, this is not what's on your notes. There, arc cosecant of a half. So if you think about that, this is asking for sine of 2. You see that? We should get an undefined here. So we're looking for arc cosecant. Wait, what's happening? Arc cosecant of a half. And yes, not a real result. And the reason is that this is undefined because the domain for cosecant doesn't include those values. It doesn't contain a half. This is undefined or not real. And we want to be able to explain, because it says explain why. Because the domain for arc cosecant of x is on the interval from negative infinity to negative 1 inclusive, and for 1 to infinity, including 1. And a half is in between these two, so it doesn't contain. The domain does not contain x equals a half. And that, my friends, is the end of lesson 9. Next time, we'll do some curve fitting.